Laser scanning vibrometry is not untypical in the industry, but I'm not quite sure it's used at the level we use it here at MISCO to really dive down and understand the root causes of problems.
Here at MISCO, we have the clipple scanning vibrometer, which allows us to scan speakers and enclosures to see their vibrational behavior. So we can see if they're matching what we predicted and if they're going to cause problems for us during production or later on for the customer.
Well, laser scanning is important due to the ability to closely examine what a transducer does. There's a number of different materials that we use in transducers, paper, aluminum, and how a transducer reacts when it's energized can be vastly different from a paper cone to an aluminum cone. So to be able to examine that and understand the anomalies that happen during its use is vastly important to understanding the actual output of the system.
Well, it plays a frequency sweep through the speaker that you're measuring from whatever, 20 to 20 kilohertz typically, and it measures point by point around the cone, usually about 3,000 points. Then it reconstructs it into a 3D model where you can look at the behavior at every frequency and see what's happening.
We want the diaphragm to move in tune with all of the surface area of the diaphragm. That's true down in frequency, lower in frequency, but as frequency increases, you can get ripples or movement in the diaphragm, and that's just inherent to the properties of the material itself. But if you don't understand how it's moving and we don't have a consistent material, you can have one side moving out of balance with the other, which will cause dropouts and distortions in the transmission of the acoustic wave. And we're always striving towards consistency in these things, and if there's an imbalance in the paper or the aluminum, that's how we find out, and that's how we correct it or take actions to make the system better.